Alright, Math 3, our trig unit review. So, got quite a few questions here. Let's dig in. Okay? All the types of things you're going to see on this benchmark. So, conversions from degrees to radians and radians to degrees. Let's take a look at those ones first. So remember, when we talk about that circle, that unit circle, we found out that in radians, half of a circle is pi, also 180 degrees. So we use that as our basis. Okay, so if we start with degrees and we want to get them into radians, we are going to times them by pi, which is representative of the radians, over 180 degrees. We want to multiply by what we want to get to over the other one. So I go 240 times pi over 180. Now I can use my calculator and just type that in and see what reduced fraction it would be. I don't want it in a decimal, and I don't want to multiply by pi yet, okay? Because most of the time they have you leave the pi out. So 24 is like 60 times 4 times pi. 180 is like 60 times 3. So the 60s cancel out, leaving us with 4 pi over 3, which is what we leave it as. Okay, so 60, same idea. So we go 60 times pi over 180. 180 we know is 60 times 3, so those cancel out. We're left with pi over 3. Okay? Now, if we have radians and we're trying to go back to degrees, then we multiply by 180, the degrees, what we want to get, over pi. And what this does is it helps eliminate our pi, first of all. Okay? Then we look to see what we can eliminate. Well, 180 is like 9 times 20. So the 9s, so I get 2 times 20. So it would be 40 degrees. Okay? So we do the same thing for number 6. So 13 pi over 12 times 180 over pi. The pi's cancel. And we see if we can simplify anything. Well, 180, 12 is like 6 times 2, right? 180 would be like 6 times 30. So the 6's could cancel, but 30 is like 15 times 2, right? So the 2's could cancel out. So then I'd be left with 15 and 13 multiplied together. Now you could just type this into a calculator and get your answer as well. So we'd get 195 degrees. Alright, there's converting. Okay, now 3 and 4 tell us if the measure of the angle is this many radians, what is the measure of its reference angle? So remember, a reference angle on the unit circle is, okay, when we go around and maybe I start my angle here and I go around to here. My reference angle is how far away it is from the x-axis, essentially, okay, in positive terms, because it's just a reference angle. So let's think of this 4 pi thirds. Now remember, the way we graph in radians is we always start here. That's our initial side. Then the denominator tells us how many slices we're going to make. So we're going to make 3 slices. So 1, 2, and then 3, 4, 5, and then 6. The numerator tells us how many of those slices we have. So I start my angle here, and then I'm going 1, 2, 3, 4. Okay, so my angle would look like that. So what is this angle? Well, it's 1 piece of 3, so it's pi thirds would be my reference angle. Okay, now if we're doing 5 pi over 6, for 6 I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for this angle, I've got 5 of those. So here's my initial 1, 2, 3, 4, 5. So my angle goes right there. Okay? So what would be that difference? Well, these each represent pi over 6, so it would be pi over 6 would be my reference angle. Okay? Alright, 7 and 8. So we've got some more radians, and we're looking, and actually we have more. Looks like we have 4 of these, right? So it says, at what point does the terminal side of the angle intersect the unit circle? Okay. Now, if you have those notes for the unit circle, this is where this is very helpful. I didn't put them on this video, so I'll just kind of freehand it and talk about it. But this is what we deal with because we have these denominators. Okay, remember pi over 6 is like 30 degrees, pi over 3 is like 60 degrees, and pi over 4 would be 45 degrees. Now pi over 2, that's like a 90 degrees or 180 or 270, okay? So we're using those special right triangles in the unit circle. Okay, that's why we can do it without any other information. But if you have that unit circle notes, that pretty much will tell you what those points are. Okay, so you look at your unit circle, and you find where 7 pi over 6 would be, and that's going to tell you. So I know it's going to be split up into 30, so it'll actually end up here because 6 pi over 6 would be 1. So it would be that angle right there. So when it wants to know this point. So in other words, I make a right triangle, right? It looks something like this. And this would be 30 degrees. This would be 90. This would be 60. Okay? Now, we've got this is x, this is 2x, and x square roots of 3. That's what the rules are, right? However, this side is 1 because my radius is 1. Okay? Which would make the short side half of that, so that's 1/2. Okay? And that's going down, so it would be a negative 1/2 to get to that point. That's our y value. Okay? Then the top here, okay, would be negative 1/2 times the square root of 3. Okay, so it would be negative square root of 3 over 2. So our point here, the x value is negative square root of 3 over 2 because it goes to the left, that's a negative x. Then it goes down, that's a negative y, negative 1/2. Okay? Could you also take the cosine of this angle and see what you get? Yeah, in a calculator you end up getting, if you calculate it, you get negative 0.866, which is a negative square root of 3 over 2. Could you do the sine of the y value of that radian and get it? And you'd get negative 0.5? Yeah. You could do it that way as well, because the calculator is set up to do that. So, you could use a calculator. That would work for all of these, but this is what's going on. Okay, number 8, we've got 3 pi over 4. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, so my point is going to be right up here. So if I make a right triangle here, pi over 4 I know is going to be a 45-degree angle. Okay, so in my triangle, we've got a 45, 45, 90. Now, normally with the pattern, the legs are x, and the hypotenuse is the square root of 2 times x. However, our hypotenuse, once again, is 1, so we're working backwards. We'd essentially say, and you wouldn't have to calculate this every time. You just need to be able to know that on your paper, you would already have these answers, and you can take a look at those notes to help you out with that. I'm just showing you once again why they are what they are. Okay, so I'd have x times the square root of 2 has to equal 1. So I divide by the square root of 2, and I get x equals 1 over the square root of 2. But we can't have that, so we times by the square root of 2 over 2, giving me the square root of 2 over 2. Okay, so both of these are the square root of 2 over 2. Now, because it's in the second quadrant, the x value is going back, so it's negative. So negative square root of 2 over 2. And the y value is going up, so it's positive, so it's square root of 2 over 2. Okay? And that's how we figure out that one. And all the 45 degree, all the whatever pi over 4s will have those answers. It'll just determine which quadrant they're in, will determine what's positive and what's negative. Once again, you could use the sine and cosine, and you would end up with the fraction or decimal version of the square root of 2 over 2, which I believe is like 0.707. So if you use, if it's multiple choice, that makes it a lot easier because you can use the calculator and go from there. Okay. Now number 9, we've got pi thirds. Well, pi thirds would be up here at a 60-degree angle in our first quadrant. So we'd make a triangle like that. So this would be 60 and 90, or 30. Let's erase that. 30, and then the right angle is the 90. So the x value here is 1/2. Because it's going right, it's positive. So we'd have 1/2 because our radius is 1. And then this one would be, we found out, was the square root of 3 over 2. Okay, just the opposite of the 30 degree. So it's going up, so it's also positive. So that point right up there, right there I should say, is square root 1/2 square root of 3 over 2. Okay. Now the final one on this section, number 10, we've got 3 pi over 2. So 1 pi over 2 would be right here. 2 pi over 2 would be pi, so 3 pi over 2 is down here. So it goes down right here. And remember, that point is, it doesn't really make a triangle, but it's 0, -1. Okay? So it would be 0, -1. And once again, you could type it into your calculator. The cosine of 3 pi over 2 would give you 0. Sine of 3 pi over 2 would give you -1. And those are those points. Okay? Alright. Now we use that same concept on these ones, right? So we've got these special angles here, these radians, and they would be points on here, but we just use either the x or the y. Cosine is the x, sine is the y, tangent is the y over x, because that's like y over 1, that's like x over 1. Secant, remember, is the opposite of cosine, so it would be the radius over, maybe I should write those, the radius over x, so it's just whatever fraction cosine is flipped. So then cotangent is x over y, and the cosecant's the opposite, the inverse of sine, so it would be r over y. Okay, so we have to do a little work on that, and once again, if you have those notes, that table, that's a great resource to helping you figure that out. Okay, you can type these into the calculator, but once again, they'll give you the decimal version. Okay, so you don't always want to do that. All right, the sine of pi thirds. Okay, well, like we said, pi thirds was like 30 degrees. Sorry, got a phone call and lost my train of thought. So I think we were trying to figure out, so pi thirds would be right here, right? So that would be the 30 part of the 30, 60, 90. Nope. Wrong. Don't let me lead you astray. That would actually be the 60 part. Because if we made 3, they would be at 60. So that would be the 60, 30, 90. So we know this part would be 1/2, and that this one would be the square root of 3 over 2, and this would be 1. Okay, so the sine would just be the square root of 3 over 2. Okay, now notice we've got the secant here as well. Okay, the secant would be the cosine would be the x value over r, so it would be 1/2 over 1, which would just reduce to 1/2. But the secant is that flipped, so it would be 2. Because 1 divided by 1/2 is like 1 times 2 over 1, so it's just like 2. So that's what the secant would be. So for that secant, cosecant, and cotangent, you've got to manipulate those numbers to figure it out. Okay. Now we also have a pi over 6. We have 2 of those, so let's look at those. Pi over 6 would be the 30, so that would be the 30, 60, 90. So the x part would be square root of 3 over 2. The y part would be 1/2, and the radius would be 1. So for cosine, we just take the x, so that'd be the square root of 3 over 2. Okay. Now the cosecant is the opposite of sine. Sine would be 1/2, so the cosecant would be the same 1/2, 1 over 1/2. So we'd flip it around and we'd end up with 2 as well. Okay. Now pi over 4 is the 45-degree angle. So we get a 45, 45, 90. And we remember this radius is 1, so the y is square root of 2 over 2, the x is square root of 2 over 2. Well, tangent is x over y. Square root of 2 over 2 over square root of 2 over 2 is 1. So the tangent is 1. Now the cotangent is the opposite of that, but doesn't matter if I flip the x and the y, they're the same thing, so the cotangent is also 1. Okay? So you can just take these fractions and you can flip them and figure them out for the opposites as needed. Okay. All right, now we're kind of taking the same idea here, but this time on the unit circle. We're essentially not doing it on the unit circle now. We're saying, like, we have this point, 9, negative 9, square root of 19. So it'd be somewhere over here. Okay? So we're essentially saying now, if we're given this point, what would that trig function be? Like cosine, sine, tangent, cosecant, secant, cotangent. So the way we do that is this basically makes that triangle again, okay, with the x coordinate being that x side, the y coordinate being that side, and the radius, us having to figure that out. Okay, so for this one, the cosine is x over r, the sine y over r, the tangent y over x. So that one's easy. So what would be the tangent of this point? Well, the y value is 5, the x value is negative 18, so it would be negative 5/18. That would be the tangent. Can we reduce that? Nope. That's our answer. Okay. Cosecant is the opposite of sine, so that would be r over y. Okay, secant is the opposite of cosine, so that would be r over x. And cotangent is the opposite of tangent, so it would be x over y. So that's another easy one. Because 4 over 4 for x would be 4, 16 for y. We'd reduce that to 1/4, so the cotangent would be 1/4. Okay, so that one's pretty easy, as was the tangent. So we've got those ones. For the other ones, we've got to figure out the r, so we use the Pythagorean Theorem. So what I would do is I'd go 9 squared plus negative square root of 19 squared equals r squared. 9 squared is 81. Negative squared is positive. Square root squared is just gets rid of it, so we get 19 equals r squared. 81 plus 19 is 100. Take the square root of it, and it's 10. So if r is 10 and x is 9, we would go 9 over 10 for our answer, for number 17. Okay? Then we do that whole process over for every piece that we need. So sine is y over r, so once again I need the r. So I go, here's my x, so negative 2 squared plus my y, 2 root 3 squared equals r squared. Now, negative 2 would become a positive 4. This part, we treat each of these separately. So it would be 2 squared, which is 4, times the square root of 3 squared would just be 3. But then I would simplify. 4 times 3 I know is 12. 4 plus 12 gives me 16. Take the square root, and we get 4 for r. So if r is 4, x is negative 2, and y is 2 root 3, we would go 2 square roots of 3 over 4. Now, I can simplify that, right? Because 4 is like 2 times 2, so I get rid of my 2. So So I'm just left with square root of 3 over 2. And that would be my answer, which is actually one of our special right triangles. Because if you think about it, this triangle it made, this would be 1, this would be, or no, this would be 2, this would be 2 root 3, so this would be 1, so you just kind of double it, works. Let's move on. Alright, now we already did tangent. Cosecant is r over y, because it's the opposite of sine. So, we've got -4 and -4. So I'd go -4 squared plus -4 squared equals r squared. So 16 plus 16, which would give me 32. Take the square root. Square root of 32 is a decimal. Normally they don't want us to do the decimal, so I'd have to simplify. That's like 2 times 16. Square root of 16 is 4, so I'd end up with 4 square roots of 2 equals r. Which this, if they're the same like that, that should tell you that that's a 45, 45, 90 triangle. So the cosecant would be the r value, 4 square roots of 2, over the y value, -4. The 4's cancel. We're left with negative square root of 2 for our answer. Okay, and finally the secant on this one. Okay, so what is secant if blah blah blah. Okay, so secant r over x, because it's the opposite of cosine. So I go 8 squared plus square root of 17 squared equals r squared. So we get 17 plus 64. Add those up, we get 81. Square root of 81 gives us 9 for r. So r is 9. So r on top, the x value on the bottom, 9/8 would be our fraction. Alright, now let's move on to using some of these rules we've learned. Okay, so in triangle HPK, which I like to draw, so HPK, HK is 7, HP is 5.5, obviously not drawn to scale. Measure of angle A is 9 pi tenths. What is the area of this triangle? And if you look at 20, 20 wants to know the formula for the area of a triangle using sine. Okay, and what is true about the two sides and the one angle? Well, if we wanted to, I could show you. Area is usually 1/2 times base times height. Okay, so if I drop a height here, okay, I have my hypotenuse here, and I have the base. Well, if I take this angle, let's call it angle H, and if I go the cosine of angle H, not the cosine, the sine, is equal to that, the opposite side, over the hypotenuse. Well, what if I times by the hypotenuse? Then we end up with the hypotenuse times the sine of angle H equals that side, H. Okay? So, that side H, in the formula, I replace, and we're going to call it A instead. A times the sine of angle H. Okay, if we called that A. So, that's our formula, and what do we have to know about it? This is what we have to know. The angle only can use the two sides that are touching it, that are adjacent to it. So the angle has to be between the two sides, like this case. We have the angle in between the two sides, then we just use the formula. So the area equals 1/2 times 7 times 5.5 times, that looks like 5 times 5, 0.5 times the sine of 9 pi tenths. Then I would put that into my calculator. Okay, I would go 1/2 times 7 times 5.5 times the sine of, making sure my calculator's in radians and not degrees, times 9 pi over 10. When I do that, I end up with an area of 5.94858. So basically 5.95 feet squared. Okay? All right. So, 25. We've got, now for these ones, we're going to look at using the law of sines and cosines. Okay? So remember the law of sines. Now, we've only got 5 minutes. I don't think I'm going to have time to finish this. So we are probably going to have to make a second video for this. Okay? So why don't I just end right here. Well, let's see if there's anything else besides the law of sines and cosines. We can hurry and look at these ones. Okay, so question 33, the frequency of the function and graph it. Once again, we had some notes on this. The amplitude, remember, it's a times the cosine of b times x minus c plus k. The amplitude is a square root of a, so our amplitude would be 3, which we'll need to graph it. Okay, our period is 2 pi divided by the absolute value of b. So b out here would be 4. So our period would be 2 pi over 4, or we reduce that to pi over 2. Okay, that's how long it takes. Now our frequency is b over 2 pi. So that would be 4 over 2 pi, which would be 2 over pi. Okay? Which, if we wanted to turn it into a fraction, 2 divided by pi would give us about 0.6, a decimal, not a fraction, 0.63, 64 actually, if I round up. Okay, so that would be my frequency. And then we need to graph it. We don't really worry about frequency when graphing. There's a phase shift, okay, and there's no midline shift. So we start here at our midline. Remember, cosine starts at the amplitude, then at pi halves it goes to the midline, a pi it goes to -1, 3 pi halves midline again, 2 pi completes its one period. Okay, for us, for ours, we're not going to move it up or down. We're going to shift it to the right, actually to the left pi fourths. Okay, so instead of starting on the x-axis here, we're going to shift this over 1, and then our amplitude is 3, so we jump up to 3. So there's where we start. Okay, our period is also pi halves, so we're going to end at pi over 4, because that's pi halves was 2 pieces. Then, just like start and end, we go to the middle and go below. So here's our start, here's our end, we go to the middle, we go below to -3. Then our midline points are between those first two and last two. So I'd kind of estimate halfway in between, and it would look something like this. Okay, very small, because of how small our period is. Okay. All right, 34. Elise played a note on her flute. Oh, let's do 35 first. How do you find amplitude of a trig function? It's the number in front of the cosine or the sine. Or if you're looking at a graph of it, you go from the top to the bottom, and then you find the difference, and then from there up, from the midline up or down. Okay. 34. Elise played a note on her flute that had an amplitude of 3 and a frequency of 1,480 Hertz. She knows this note can be described by a sine function with no horizontal or vertical displacement. Write an equation to describe this function. There is a few typos here. I think I noticed one somewhere else too. Anyway, apologize for those. I swear I read through this, but I just missed a few, I guess. Okay, so we know the amplitude is 3. We know it's the sine. So f of x equals 3 times the sine of b times x, or times theta. So that's what we need to figure out. So f equals b over 2 pi, put 1480 times by 2 pi, we get 2960 pi